Let's look at the question 2, part D from the test 1. The question goes like this. Standing at the top of Clough Commons, you throw a tugboat into the air, giving it an initial momentum of P initial equals to 20, 50, 0 at time equals to t equals to 0. Sometime later, it lands on the ground a vertical distance of 20 meters below. On the graphs below, stretch the x component and the y component for the momentum of the tugboat during its complete flight as a function of time. The only force acting on the tugboat is due to gravity. So we first look at the x direction of the momentum, which is 20 at the initial. However, according to the momentum principle, which states that the change of momentum equals to net force times the time interval. And in this situation, the boat experienced no net force in x direction, which means the net force equals to 0. So the change of momentum should also equals to 0. It begins with a positive momentum, so we can draw a straight line above the x-axis to demonstrate this. Second, we analyze the momentum change in the y direction. Again, according to the momentum principle, the change of momentum equals to the net force times the time interval. And in this situation, the net force is only gravity, which is a constant. So we can conclude that the momentum in y direction change at a constant pace. And according to the problem, it begins with a positive number. So, and the change of momentum should go in the same direction with the gravity, which points to the minus y direction. And it finally hits the floor, which demonstrates that the objects at the last half of the flight have a y direction momentum pointing to the minus y direction. So we can draw a line goes like this. To represent how the momentum begins with a positive y direction momentum and ends with a minus y direction momentum.